right, guys. Today we are going to be talking about still evaluating trig functions on the unit circle. We're going to be focusing in on our day 3 here. And the new content that you're going to learn about today are what if you're given an angle that still has a reference angle of 30, 45, or 60, but it is not in between 0 and 360. So we'll be looking specifically at that. And then we will also be learning how to evaluate trig functions of non-unit circle angles, so angles that do not have reference angles of 30, 45, or 60, by using our calculator. So please make sure to have your calculator, your graphing calculator right next to you so you can follow along with my steps that I'll give you today. I want you to start out by giving this warm-up a shot. So I'm going to pause the screen, and I want you to state the reference angle of the angle that's given and which quadrant the triangle, if you were going to draw it, would be in. For 240 degrees, you should have gotten that that lands in the third quadrant with a reference angle of 60 degrees. Negative 330 starts at the x-axis and goes backwards. Doesn't make it all the way to negative 360, stops in the first quadrant. And if you're thinking about how far away it is from this x-axis, if that's negative 360, they are 30 degrees apart. Notice how even though our angle is negative, our reference angle is positive. Negative 5 pi over 4. Let's talk through that one. You're starting at the x-axis, and you're going backwards negative 5 fourths pi. Now think about negative 5 fourths. That's larger than 1 whole pi. So we have negative 1 fourths, negative 2 fourths, negative 3 fourths, negative 4 fourths. So this is at negative pi. Now we just need to go negative 1/4 more. So you should land in the second quadrant. And your reference angle, remember anything that lands in pi over 4 has a reference angle of 45 degrees. So you should have gotten quadrant 2 with a reference angle of 45 degrees. 5 pi over 3 gets us all the way to quadrant 4. Anything that lands in pi over 3, ends in pi over 3 has a reference angle of 60 degrees. So this should be quadrant 4, 60 degrees. Check those out. I'll zoom out there. Check your work again. Make sure you've got those all down pat. First of all, with our problems today, I'm not going to ask you to evaluate all 6 trig functions. I'm just going to zoom into a particular trig function I want you to find. So cosecant of 7 pi over 6. The steps really aren't going to change from days prior. You're just only finding one trig ratio, not all 6. So first of all, think to yourself where 7 pi over 6 lands. It's a little bit bigger than 1 whole pi. Should land in the third quadrant. Anything that ends in pi over 6 has a reference angle of 30 degrees. Form your right triangle with your x-axis. Fill in your remaining angle, and let's fill in our sides. Now, pause. Always check for negatives. So this leg should be negative because you're moving left on the coordinate plane. And this leg should also be negative because you're moving down on the y-axis. The hypotenuse is always positive. So in this problem, we are asked to find cosecant. Cosecant, remember, is the reciprocal of sine. If sine is opposite of hypotenuse, we're going to do the hypotenuse over the opposite. We'll label our sides of our triangle and fill in the hypotenuse, 2, over the opposite, negative 1. So the cosecant of that angle is simply negative 2. We don't have to find all 6 today. We are just asked to find the cosecant. Let's give it a shot with this problem to the right. Negative 240 degrees. Take a minute and figure out which quadrant that's going to land in. If we go backwards, since it's a negative angle, we get to negative 180. It's going to be farther than that, but it's not going to be as far as negative 270. So it should land in the second quadrant. To find your reference angle, think about how far negative 240 is from negative 180. It is 60 degrees away. Again, even though our angle is negative, our reference angle is always positive. Form your right triangle with the x-axis, fill in your remaining angles, and now let's fill in your side lengths. Before you continue, check your signs. Moving left, you should have -1. Moving up, you should have positive square root of 3, and your hypotenuse across from the 90-degree angle is always positive. Label your sides, O, A, and H, and this time you can see that we are asked to identify the secant. Remember that the secant is the reciprocal of cosine. Cosine is adjacent over a hypotenuse. The secant is the hypotenuse over the adjacent. So we have the hypotenuse is 2, the adjacent is -1. 2 divided by -1 gives us a secant value of -2. Let's move right along. This next one, you'll see we have an angle of 675 degrees. 675 is obviously larger than 360. So we need to find out what that reference angle is going to be, or which quadrant it's going to land in, by finding a coterminal angle. Remember, to find a coterminal angle, we start with the angle 675, and we're going to subtract 360 because that is currently over 360. 675 minus 360. You should end up with 315 degrees. 315 degrees is now an angle that is within our unit circle angles. So figure out which quadrant 315 degrees lands in. Remember, it's bigger than 270, smaller than 360, so it should land in the fourth quadrant. The reference angle is the angle that is formed between 315 and that x-axis, so figure out how far apart 360 and 315 are, and you should get 45 degrees. Draw your triangle formed with your x-axis, right triangle, and then fill in your remaining angle. You know your legs are 1, 1, and the square root of 2 is your hypotenuse. Check your signs. If we go right on the x-axis, we get +1. If we go down on the y-axis, though, this should be a -1. Hypotenuse is always positive. Label your O, your adjacent, your hypotenuse. And now you can see that I've asked you to find the sine. Sine, of course, is the opposite over the hypotenuse. So fill in your opposite side over your hypotenuse, rationalize it out, and you get negative square root of 2 over 2. Let's do the same thing with an angle that's too large for our unit circle, but this time with radians. 11 pi over 4 is bigger than 2 pi. We can recognize that by thinking about how many times 4 goes into 11. It goes in 2 with 3/4 change, right? So we're going to have to find a coterminal angle by subtracting 2 pi. Oops, I didn't mean to do that. So let's take the angle first, 11 pi over 4, and find a coterminal angle by subtracting 2 pi. Now, if you get confused in this next step, always just take your calculator out and do 11/4 minus 2, and then change it back to a fraction. If you want to do it by hand, we're taking 11 pi over 4, and we have to change 2 pi to have a denominator of 4. Multiply it by 2, we get 8. 8/4 is the same as 2 pi. 11 minus 8 is 3 pi over 4. So you'd subtract straight across, your denominator stays the same. So now, this is the same thing as asking us to find the tangent of 3 pi over 4, because 11 pi over 4 and 3 pi over 4 are coterminal angles. So think about this as your new problem. Think about where 3 pi over 4 lands. It's 3/4 of the way to pi, so it should land in the second quadrant. Remember, anything that lands with pi over 4 has a reference angle of 45 degrees. Fill in your legs. Check your signs. Label your opposite, your adjacent, your hypotenuse. In this problem, we're asked to find the tangent, as you can see up here. 1 over -1, your final answer should be -1. So to review there, if your angle in radians is larger than 2 pi, subtract 2 pi to find a coterminal angle. You can either use your calculator to do that or find a common denominator. Subtract until you have a unit circle angle that is in between 0 and 2 pi, and then continue your steps from before. Now, another option that you could have done here is back with this 11 pi over 4, if you hate radians, you can always change that to a degree, and just like the problem to the left, you could have subtracted 360. That would have still gotten you, it would have given you an angle of 135, and then you would have proceeded just like normal. Let's move on right along. This next one, cosecant of 7 pi over 2. 7 pi over 2 is obviously bigger than 2 pi because 2 goes into 7 3.5 times. So let's take 7 pi over 2 and find a coterminal angle by subtracting 2 pi. So we're going to take 7 pi over 2, and we need to subtract 2 whole, so it needs to have a denominator of 2. Take 2, multiply by 2, we get 4. 4 pi over 2 is the same thing as 2 pi. Again, if that confuses you, simply plug it in your calculator. 7 halves minus 2. Math, enter, enter. We'll turn it back into a fraction for you. So we have 7 minus 4 is 3 pi over 2. So what this is asking us to find is the cosecant of 3 pi over 2. 3 pi over 2 is a unique angle because where does it land? Bam! On an axis. 3 pi over 2 is the same thing as 270 degrees. So before I continue here, just remember, if you hate dealing with this, 7 pi over 2, change it into degrees by multiplying by 180 over pi, and then subtract 360 from there, and you would have gotten 270 degrees. Either way is absolutely fine. Now, remember when we deal with an axis angle, we use the ordered pair. So if we go directly down on the y-axis, you don't go right or left at all, so that's a value of 0 for your x and negative 1 for your y. Label your x value your cosine, your y value your sine. Now you'll notice in this problem, we're asked to find the cosecant. The cosecant is the reciprocal of sine. Reciprocal of sine. So if you'll notice that the sine is equal to negative 1, we can stick that over 1. If we flip that around, 1 over negative 1, we still get negative 1. So the cosecant of 7 pi over 2 is negative 1. Go ahead with this last one on this front page and find where negative pi over 3 is. Negative pi over 3 goes backwards 1/3 pi from the x-axis. Anything that ends in pi over 3 has a reference angle of 60. Go ahead and pause the screen and fill out the rest of that problem. Check yourself before turning to the back side of the notes. You should get that the cosine of negative pi over 3 is 1 over 2. On this back side here, it's going to be important that you have your calculator, because all the angles that we're going to be dealing with on this backside are angles that aren't key unit circle angles, but you can still find the trig function of them. You just have to use your calculator to help out. So first things first, when you're using your calculator to evaluate a trig function, you'll need to recognize these things. First of all, if the number has a degree, you use degree mode. On the other hand, all other times, meaning if it has pi or it just has a number. So if there's just a number with no degree, all other times you use radian mode. Now this mode that I'm referring to is a mode that can be found on your calculator. And I'm not tech savvy enough to switch screens and show you this on the calculator. So to find the mode button on your calculator is to the right of the blue second button. If you click on that and go to the fourth line down, you'll notice that it says radian or degree. Toggle over the one that you want the mode to be in, radian or degree, and press enter. So for example, on this first one, tangent of 304 degree, you'll notice that it's in degrees. So we want to use degree mode, obviously. So you'll go to mode, go down to degree, press enter, push second quit to get out of there, and then your sine, cosine, and tangent buttons are directly above the, like they're 2 lines above the 7, the 8, and the 9. So you'll just press tangent of 304 and press enter, and you know you've done it correctly if you get negative 1.4826, we'll round it to. Secant is not a button on your calculator, but secant is the reciprocal of sine. So if you're finding secant on your calculator, you'll do 1 divided by the cosine of 72 degrees. We're going to keep it in degree mode because obviously we see a degree right there. So in your calculator, do 1 divided by cosine of 72. It's still in degree mode. You don't have to put in degrees or anything. And you should get 3.2361 if you've done it correctly. You'll notice that both the problems in this bottom row don't have a degree. The negative 11 pi over 8 has a pi, so that makes it pretty obvious that it's in radians. But this one to the right, cosine of 3, doesn't even have a pi or anything. Because it doesn't have a degree, both of these are in radian mode. So you'll need to go back to your mode screen, go down to the 4th line, change it into radians, and now cotangent. Cotangent is not a button on your calculator, but we know that its reciprocal is tangent. So we'll do 1 divided by the tangent of that whole fraction, negative 11 pi over 8. Let's try it out. You have 1 divided by tangent of negative 11 pi divided by 8. Close your parentheses, and you know you've done it correctly if you get negative 0.4142. Let's do the same thing with cosine of 3. That should go pretty quickly because it's just a cosine. Cosine is a button included on your calculator. So plug in cosine of 3, press enter, and you know you've done it correctly if you get negative 0.98999. You only use the calculator if you're given an angle that is not a key unit circle angle. Otherwise, I expect you to answer precisely with your radicals and all that fun jazz, special right triangle stuff like you did the rest of the week. All right, log back in, especially if you have questions on where to find these buttons on your calculator. See y'all soon.